Hi, I'm Danish. I'm a part-time PhD student at IIT Delhi. This talk summarizes our work on constrained BERT BiLSTM CRF for understanding multi-sentence entity-seeking questions. This was recently published in the Natural Language Engineering Journal in January 2020. Let's begin with an example. My husband and I are traveling to San Francisco with 3 daughters in their young 20s in October this year. What would be a good hotel to stay near Fisherman's Wharf? Something not too expensive, but convenient to the majority that first-time visitors. And this is a grammatical error. We will not have a car, just using public transportation to get around. Any input for a first trip there, definite size to see, be welcome. What are the challenges in answering such a question? It's a long question with multiple sentences. Not every sentence is important for answering. For example, the last sentence is a question. And the answer to this question is subjective. If you were to think about how you would answer this question, you might want to first figure out what words or phrases are important for answering this question. The user is looking for a hotel, so that's definitely important. The user has specified some properties or attributes of the hotel that they're looking for. And of course, the location of where they're wanting. Now recall that we want to build an answer for a question like this. And let's say we're given some black box knowledge source, like the Google Places API, or some structured or semi-structured knowledge base that has got names of entities such as hotels, restaurants, and attractions. To get answers from this KB, you would need to generate a query and then retrieve responses from this KB to give you the answer. How do you get such a query representation? In this paper, we present the novel task of understanding multi-sentence entity-seeking questions. We do this by building a semantic representation of a question that is open, which means it makes no assumptions about the schema of the knowledge base. We build this with very little training data. And since we rely on very little training data, we use our knowledge about the task and encode them using features and constraints. We present the first system that is able to answer such real-world complex questions. Let's look at our example again. The phrases that we thought were important could be mapped to 3 open classes. Type, indicating the target type of the answer entity, which is hotel in this case. Attribute, this long phrase specifying the user preferences or constraints about the entity. And location. If we were to think of each word in this question as either belonging to one of these classes or a generic fourth type called other, we could transform this question into a sequence tagging problem to get labels. Like I mentioned previously, we also want to use very little training data. Is there some task knowledge we can encode? Well, yes, we can. Every question needs to have at least one type label because questions are seeking information. We need to have some attribute labels, but it's not necessary. We implement these using constrained conditional models. The paper described details of how we use a neural network model with constrained conditional models to build a tagger that labels each question. But assume for now that we have a labeled question. How do we query a knowledge base? Let's say we have a knowledge base that accepts text-based searches. We use the Google Places API to demonstrate our work. We concatenate the tokens labeled attribute, type, location, along with a user input about the city. We detect and remove any negated attribute labels. And here's an example of a query that was generated. Great cheap romantic Italian restaurants in Vasant Kunj, where great cheap romantic comes from the attribute label, and restaurant is our type, and Vasant Kunj is our location. We query Google Places API and return entity answers that satisfy this query. We find that our model answers 42% more questions with 56% more recall as compared to some baselines we implemented. Details are available in the paper. But as an example of questions we get right and wrong, in this first question, the user is looking for recommendations about dinner on Christmas Eve, and this recommendation is correct. Whereas in the second question, where the user is looking for a hotel that is walking distance from a market, the return answer entity satisfies other constraints, such as being a budget hotel and so on, but it does not meet the location constraint. Please read our paper to understand more about our work. Our follow-up work considers this problem end-to-end, that is, using an end-to-end neural network that answers questions by reading a collection of entity reviews instead of using a knowledge base like Google Places. And we've now also developed methods that can jointly reason on geospatial data and textual reviews. Thank you for watching.